We've now learned how to construct and interpret confidence intervals, and to use confidence intervals to understand the potential level of error in our sample estimates. We'll take it a step further now, using confidence intervals to test hypotheses about the population. Consider an example. Suppose that 25 extraterrestrials, or ETs, have landed on Earth. The observed relationships between ET brain weight and height, as well as between brain weight and hand length, are shown here. Notice that brain and hand are in quotes here because, of course, ETs are different than humans. For example, their hands, quote unquote, don't necessarily look like human hands. Further, let's assume that all of these measurements were taken with the highest ethical standards. Then take a minute to pause the video and ask yourself the following inferential questions. Based on this sample data, what can we conclude about the broader population of ETs? Is there a significant relationship between brain weight and height? What about between brain weight and hand length? So I don't normally like trick questions, but these trick questions happen to illustrate a very important point. We cannot use our sample data to make inferences about the population without an understanding of the potential error in our sample estimates. This is true for ourselves and everyone else. Unless they report levels of potential error, we cannot trust another researcher's results. Thus, let's try it again. The following plots include the observed sample data points, the estimated sample models in blue, and confidence bands in gray that reflect the potential error in this estimate. These confidence bands are like confidence intervals, but for the entire model trend. Though there's error in our particular sample model, we're confident that the actual linear trend falls somewhere within these gray bands. So pause the video again to revisit our original questions while taking into account this potential error. Do we have enough evidence of a significant relationship between brain weight and height? What about between brain weight and hand length? In the case of brain weight versus height, the answer is yes. If there were no relationship between these two variables, we'd expect the trend line to have a slope of 0. Yet no matter where we put it on this plot, a zero slope line does not fit within the plausible trends indicated by our confidence bands. Or it's out of the realm of possibility, according to our sample data. For the opposite reason, in the case of brain weight versus hand length, the answer is no. A model trend exhibiting no relationship, that is, a zero slope line, fits comfortably within our confidence bands. This is a real possibility. Oh wow! Suppose that a total of 500 ETs have now landed on Earth, providing even more information about ET brain weight, height, and hand length. Based on this new sample data, what do you think now? Do we have enough evidence of a significant relationship between brain weight and height? What about between brain weight and hand length? In short, the answer to both questions is yes. In both cases, model trends exhibiting no relationship don't fit within our confidence bands. Yet, if you look carefully, we have to be a bit cautious and get into the habit of considering the nuances in answering inferential questions. Notice that we mainly came to the new conclusion about the relationship between brain weight and hand length as the result of a larger sample size. We've seen before and can see in the series of plots throughout this video that as sample size increases, our standard errors decrease, or here our confidence bands got narrower. As a result, notice that it becomes easier to establish statistical significance. mainly our bands for the relationship between brain weight and hand length, have narrowed to the point that even though this sample trend has a very small positive slope, the bands themselves no longer cover a zero slope line. This here is the rub. Statistical significance indicates the presence of an effect or the presence of a relationship. Or here, since a zero slope line isn't included in the confidence bands, we have statistically significant evidence of a positive association between brain weight and hand length. Yet statistical significance doesn't always indicate a meaningful significance. Thus, even if a relationship is shown to be present, it's up to us to determine whether the magnitude of this relationship is actually meaningful in the context of our analysis. To this end, we have to pull together all of the pieces, not just is the relationship statistically significant, but exactly what relationship did we observe? How big is the slope? How strong is the relationship? Answering these more nuanced questions requires some contextual knowledge, which I happen to not have about ETs.